In this video, we're going to take a look at some features of the quadratic, specifically the vertex of a quadratic. This goes with the previous videos that we talked about graphing transformations, at least for the first part. So we've got two different forms of a quadratic. The one is the one that we looked at before, where you have f of x or y equals and this is called the vertex form in most books, and this is the form that we looked at before. So if you remember what we talked about with graphing transformations, the a is the number up front, that's what's multiplying the quadratic. So if a is greater than 1, then it's a stretch in the y direction. If a is less than 1, we compress in the y direction. And that's actually just the value of a. And if a is less than 0, then it's a parabola facing down. And of course, if a is positive, that's just our regular parabola facing up. Alright, so that's all decided on a. Okay, if a is like 2, 3, 4, it's going to be a stretch in the y direction, which makes it look more narrow. If it's 1/2, 1/3, 1/4, things that are less than 1, then it's going to compress in the y direction, which makes it look more wide. If you have a negative out front, it's going to be a parabola facing down. If it's positive out front, it's going to be a parabola facing up. So we looked at all that stuff in the last video. Now remember the h and the k, those were our numbers outside and inside. So on the outside, if you add a number to the outside, that's going to shift us up or down. So k is the amount that we're going up. And then h here, if you look, they put it with a negative. Remember, the number on the inside is left and right, but it's opposite what you'd expect. So h is going to be the shift to the right if h is positive. Okay, so k tells you to go up or down, h tells you to go left or right, depending on if it's positive or negative. And so really that's telling you what the vertex is going to be. We'll look at this with some numbers in just a second. But the vertex is going to be hk. So k is going to be the same sign, that's the up or down. H is going to be opposite sign because remember it's left and right, but it's opposite what you'd expect. So if it's negative, it's going to shift to the right. If it's positive, it's going to shift to the left. And then the A tells us what's happening with the stretch and compress, but that doesn't tell us where the vertex is going. Remember, the vertex is that high or low point on the graph. So let's look at an example in vertex form. Let's say we have y is equal to 2, x minus 3 squared minus 4. So in the last few videos, we talked about transformations and what this is going to do to the graph. So the 2 out front, that's going to make it a stretch. It's going to make it look more narrow. The minus 3, that's on the inside, that's going to be opposite what we'd expect. So it's going to take us right 3. And then the minus 4, that's on the outside, that's going to take us down 4. So we're going to go right 3, down 4. So our vertex is at 3, negative 4. And then we're going to, it's positive, so it's going to be facing up, and it's going to be a little bit more narrow. And for right now, we're just going to go ahead and sketch that in, just to remember what it looks like. But you can see here that the vertex is at 3, negative 4. So you can go directly from the equation to the vertex by remembering that it's opposite sign, same sign. So look here, opposite sign, positive 3, same sign, negative 4. So let's just do that for a few examples and get the vertex. So for this one, what would the vertex of this one be? It would be opposite sign, negative 2, same sign, negative 5. So negative 2, negative 5. Or you can think of it in terms of shifts, left 2, down 5. Either way is perfectly fine. Let's try another one. Let's say we have x minus 3 squared plus 7. So this is going to take us to the right by 3, and this is going to take us up 7. So right 3 and up 7, or opposite sign would be positive 3, same sign would be positive 7. So right 3 up 7, or opposite sign, same sign. Okay, now what if one of those numbers is missing? If one of those numbers is missing, then it's just going to be a 0. So we've got the number on the inside that's going to shift us left by 4. We've got no change on the outside, so we're just going to shift left 4. Or in other words, we've got opposite sign would be -4, same sign would be 0. So it's going to be -4, 0. And if we have one that looks like this, there's nothing on the inside, so that's a 0. And then on the outside, we've got the +3. So no left or right, just up 3. We're going to land at 0, 3, or you can think of it as opposite sign, same sign. So opposite of 0 is still 0. So we've got 0, 3. All right, so whatever makes more sense to you, whether you think of it in terms of shifts or opposite sign, same sign, that's totally fine. Okay, and we can deal with ones now that are in vertex form, because we remember that all from shifting. All right, now what if they're not in vertex form? Let's take a look at that. Okay, not in vertex form is standard form, and that's actually the form that we've looked at before. You can look at f of x or y equals, and then we've got ax squared plus bx plus c. So you should remember that from the quadratic equations that we looked at. This is now a quadratic function. Okay, so this is in standard form, or general form, if it's an equation. So this is in standard form, and in this form we can't see the vertex. We can't see the shifts. We can't see the vertex. So we've got to do something else. So one method would be to complete the square to get this in the right form. Remember, we did that in another section. We completed the square to get this in the right form. For most quadratics, that is not easy to do. You end up with fractions and all sorts of ugly stuff, and it's just not a lot of fun. So the shortcut, instead of putting this in standard form every time, if you put this in standard form in general, what happens is that the h part is always going to be -b over 2a. So you take this and you put it into standard form, into vertex form by completing the square. And what happens is that this h right here, this position, is always going to be -b over 2a from what you had originally. So rather than put it into vertex form every time, we can just use that shortcut and know that the h part of our vertex is going to be -b over 2a. So you can find the vertex by using h equals -b over 2a, where the vertex is hk. And anytime that you have an x value and you want to find the y value, you just take that and you plug it back in. When you put this into vertex form from standard form, there is a formula here, but it's messy and it's a pain, and I never remember what it is because it's much, much easier to just plug it back in. So you may see a formula for the k in this book or in other books. To me, it's not worth memorizing it. It's not worth even using it because it's much easier just to plug the value that you get back into the equation and see what it comes out to be. So let's take a look at that so you can see what I mean. All right, let's say that we've got y is equal to x squared plus 6x minus 3. All right, and we want to know what is the vertex. Again, we can't look at this and just know what the shifting is going to be or what this is going to look like, so we've got to do a little bit of work. So we're going to use h equals -b over 2a. Okay, just like with the quadratic formula, this is our a, this is our b, and this is our c. So we see that b is 6, and then a is 1. So I'm going to have negative out front, 6 over 2, that's going to give me -3. So the h part of my vertex, the x-coordinate, is -3. And then to find the k, I'm going to plug it back in. So I'm going to plug it back into the equation. So I'm going to have -3 squared plus 6 times -3 minus 3. Be real careful on your order of operations here. So I'm going to get +9 minus 18 minus 3. That's going to give me -12 overall. So my vertex is -3, negative 12. Okay, and if I needed to draw it, 1, 2, 3, 4, 5. Okay, my vertex would be way down here. And then the other thing that we know is that this A right here is actually the same A as this right here. So when you rearrange these equations, those A's are the same A. The leading coefficient is the same for both. So we also know from looking at our equation here, we do it in purple, we see that our A is positive 1, and we know what that means. That means that we're the normal size and we're facing upwards. So we could sketch this in from here. Normal size parabola facing upwards looks something like that. Okay, so between the vertex and the A value, you already know something about the graph. All right, let's try another one of these. Let's say that we have y equals 2x squared minus 3x plus 4, and we want to find the vertex. So the vertex is going to be, oops, negative b over 2a. So this time a is 2, b is negative 3. We don't actually need c, but I'll mark it anyway. So we're going to have negative 3 over 2 times 2. Negative negative is going to come out positive, and I'm going to have 3 over 4. 3 over 4. Okay, so this one's going to come out to be a fraction. That's okay because we can use our calculator to plug it back in. You just got to be careful with order of operations. Okay, so we're going to plug that back in. I actually don't have that number in front of me, so hold on just a sec. We'll do it together. Okay, so when you're putting this in your calculator, make sure that the 2 is not part of that square. So we're going to have 2 times 3/4 squared minus 3 times 3/4 plus 4. And I get 2.875. And just to be consistent, I'm going to go ahead and change that to a decimal as well. So they can come out a little bit messy, and that's okay. Okay, 0.75 and 2.75. That does happen sometimes. Life isn't perfect, right? Okay, and that's our vertex. And the other thing that we know is that the leading coefficient is 2. It's positive, so it's facing up. So we have our vertex, and we know that it's facing up.